Hey everyone! I know I said I was going to stream yesterday, and then that did not happen. And that didn't happen because it turns out that I don't like getting up at 6 a.m. And so I took Carolyn to what's it called? That place with the thing and the stuff, airport. And so Professor is right behind me because Carolyn isn't here, and so second favorite mommy. Get some extra professor time these days. Yeah. And anyway, so yesterday I just really wasn't feeling going on stream, so I just like did normal job stuff instead. But I'm back, and yeah, hopefully we can do some fun streaming. I'm gonna go bring up the YouTube thing. Oh, let's power cycle this. And we're gonna go over here. That. Okay, cool. So, bit of a slow start today because life. I made a smoothie. It is not great. I ran out of blueberries. And it turns out a blueberry coffee spinach smoothie is like so to begin with, and then when one runs out of blueberries, kind of not great. Let's be honest. Yeah. Anyways, so what are we hacking on today? So we are continuing the work that we were working on Monday. I want to say the days of the week are all fuzzy now, but it's only Wednesday, so it's probably Monday. Where we were doing stuff. What were we doing? My brain. Okay, yeah. What we were doing is we were working on making UDFs, transpile, from Python into Catalyst expressions. Timbit's upset. There may or may not be someone at the door. We'll find out in a minute. But we're going to make it work. What's the latest? Oh, okay. Okay, that might be Melanie. We'll see. Okay, let's do some more hacking. So, hey, Professor. Professor. I just want to make sure that the professor hasn't run away. Professor baby. Good job. Good job. Okay. Let's go ahead and bring up the Spark stuff. Cool. So, definitely not this. Okay. And, oh yeah, it's going to be terminal view. Fantastic. Okay. So, then where are we off? Okay, let's go take a look at our git log. So, where did I end up doing this? Right, okay. It's coming back to me. And so, in fact, here's what we're going to do. So from what I remember of where we ended up leaving off, essentially the problem was our optimizer rule changed the state of UDF underscore sanity, I want to say. Bin spark submit UDF sanity. We'll wait for the package to run. But yeah, so essentially the problem here was that we so in our UDF transpilation, Python UDF.scala. Yeah. So, right. So here, I want to say in convert func, yeah, when we're going ahead and if we've got a name, we just go ahead and we grab that parameter index, right? And that's fine. That makes sense. The problem is the child that we pull, so params index of, is it an expression, but it's an unresolved expression. Now the question is, how do we either get a resolved expression, or can we do the transformation earlier enough that all of the expressions are unresolved, so it doesn't really matter that we're coming back with an unresolved expression? I don't know the answer to either of those. It's been a long time since I poked around inside of the optimizer, so let's go find out. Cool. Yeah, convert to catalyst and batch operator before inferring filter has generated an invalid plan. The plan was previously resolved and has become unresolved. Okay, so fudgesicles. Now, okay, so okay, wouldn't be children directly. Optimizer dot scala unresolved. Don't. Okay. Not quite what we want. Is it? Transform up with pruning dot child. And this is the thing, like dot children, so like it's a sequence of expressions. I don't think we can go with dot child directly, right? Like where does the resolution take place? Oh god. So like, yeah, here we see like, yo, we've done this copy and that's fine. But when we do things with oh no, yeah, okay, when we do things with the children, it explodes because of reasons. I'm not entirely sure why us getting the child object here, did they do something different here in local limit? This is transform with pruning, plan transform with pruning. We both work on logical plans. Okay. Oh. Transform with pruning? Okay. I quit Discord. Why am I still getting Discord notifications? Fill all of Discord. Dash S9. Fantastic. All done. That should not. Okay. Trying to replace with Catalyst Expert which has children, and catalyst expert dot children respectively. Okay, cool. That'll be something. Rebuild the package. Oh yeah, shit, we have to return the catalyst expert. No, we do. Oh, Python syntax. That's not how we print. Yeah, open a log warning. Ooh. Okay. Okay. Transform with pruning. Yes. Why is it not liking that type? What? And transform with pruning. Python UDF. Electrical, like, transform with pruning. Funky monkey. Funky monkey, indeed. Like, that should work. Oh. 1 second. Making sure it's a packet. Okay, buddy. Okay. It's the mailman. Crisis averted. Crisis averted. Okay. Let's keep going. So. Ooh, nope, not what I wanted. Yeah. What? Yes, I don't. Did not mean to do that. Okay. Yeah. Okay. So that's the thing, like, right before, when it was happy, we had resolve expression with pruning. Okay, let's go back to resolve expression with pruning and see, is that actually transform expression? Okay. To catalyst. So catalyst is the name of Spark's internal representation for data frame operations. Okay, so that builds fine. Okay. So the type signature that we're getting back from transform with pruning is different. So let's go and dig into this. Yes, sure. Okay. So recursively transform the expressions of a tree skipping nodes that have already been analyzed, yeah. And you take a rule, which is a partial function from expression to expression. Okay. So that seems... And the pruning is a condition which lets us quickly say, like, yo, I apply here or not. Resolve bottom up transfer. I mean, we could try resolving up, but I don't think that's going to make a huge difference. Transform down with pruning. In analyzer, use resolve operators down instead. Transform up with pruning. Okay, well, resolve expression. And the one that we're doing is to catalyst. Supposed to try resolve expressions down, and then we wouldn't. Oh, we could do resolve expressions down with pruning. Okay. Well. Okay. It doesn't. $985. Fine. Yeah. All right. So that'll resolve the expressions of pruning. And then run this. And then hopefully we'll get a bit of an understanding. Oh, fuck. Did I forget the annotation? Oh, right, because we made it multi-line. Damn it. Okay. Now that it's multiple lines, we have to put the format string annotation on each line. I know, Professor. Okay. And at the very least, hopefully that'll give us a bit of an idea as to what's going on with the why it's saying it's unresolved. Trying to replace lambda number with, which has children, vector number. And vector number 0. Interesting. Why is that? Why is that happening? Catalyst expert. Interesting. Another. Okay. My little baby is having a hard day with all of the packages coming. Okay. Interestingly enough, which I'm a little bit surprised at, um, we're seeing that we're replacing this with this. And honestly, it looks like there's more information on the right-hand side. Oh, wait, no. Well, I guess literal is new, technically. But that, is it the literal that's... Maybe it's the literal that is not resolved. Let's go find this. Okay. This has to come from somewhere. Error conditions. Okay. Let's go take a look at error conditions. Actually, let's go take a look at the name of the error class that we've got. Oh no, it's just generic spark exception. Cool, that's not very useful. Yeah. Damn it. Okay. The plan was previously resolved and has now become unresolved. So the question is, like, what exactly has become unresolved? Okay, so let's go take a look at logical plan. Oh, actually, we can go. Okay. Okay. Now I want the full validation so I know what the hell it is that broke. Because I'm not entirely 100% sure what it is that broke our resolution. It could be the new literal that we added, but the literals shouldn't require resolution, and the child hasn't changed otherwise, but I guess the literal is new. So that could be it. It could be the new literal that we've introduced, which is breaking it, which would be really annoying. Okay. Yes. Yeah. Which of these are unresolved? Yeah. Okay, that's got. Oh. Okay. So this itself has become unresolved. I think. I think. So if we replace a node. Uh, okay. Okay, no, we don't actually want to execute that Scala. Okay, yes. Okay, I think we might be onto something. Um, yeah, fine. So, um, yeah, what we do everywhere else is we'll take this and we'll make, although actually we do introduce new filters all the time, right? We do introduce new filters all the time. So maybe that's not it though. Although it could be because it is like an actual, like the filter itself doesn't output anything, the projections do. Um, let's go take a look. Um, okay, let's look at unresolved. Um, hmm. Uh, I mean, I guess we could redo the resolution, but that seems like overkill. Can we just? I guess the other question is like, can we just do this before resolution? Uh, Probably not. Uh, um, uh, well, okay, wait. And so we put this in just kind of this like big default batches. Okay, push projection through and Operator optimization batches. Final analysis. Eliminate distinct inline CTE. Local relation early, pull up correlation, so query, replace operator, pre-CBO rule. Oh, cool. Yeah, I mean, like, this stuff is hard to do, and the AIs do not do fantastic at this. Um, it's, I mean, and maybe they'll get better at it, right? Like, train them on more of this. But, yeah, this stuff is kind of gnarly. But also, hi, Rugba. The other thought is, I'm lazy. What about if we just move this into operator optimization batch? Right? Like, can I just move this batch up? I feel like this should work, right? Reorder join. Like, if we go look at reorder join. Oh, okay. So resolve expressions with pure name. Like, you should be resolving my expressions. Lazy. Okay. Yeah. Okay. Um, resolve. Which one? I can go with this one. Column expression suite Scala. Oh no. Okay. Okay. Previous plan dot resolved. Okay. Go find logical plan. Okay. Resolved. So if this expression children are resolved. So okay, let's go over here to optimizer. Um, Okay. Uh, Solution. Okay, dollar sign. Uh, um, so the question is it the children that are not resolved, or is it the expression itself which is not resolved? Not entirely sure, and we are going to find out. It's going to take a hot minute, though. And then, so the other thing that I've been thinking about is that, like, yeah, even if we do this in on the Python side, I want us to pass through both the UDF and the catalyst converted expression so we can swap between the two because there's a cost of essentially switching in and out of UDFs, and we can do smart optimizer things to minimize that cost. So if we chain a bunch of UDFs, it's actually better. Cool. Now, tell me. Okay. Okay. So the children are resolved. It's the new thing that I've made that is not resolved. Fantastic. I love that for absolutely no one. But, okay, at least it's not the constant. So that makes sense, logically speaking. So why the fudgesicles is this not working? Okay. Well, you are inside of limit pushdown. Let's go find where limit pushdown. You're right there. You make so this applies and it makes new. Oh, it takes an expression as the input. Okay, okay, I'm feeling something. Maybe. That's not what I want. Damn it. That's the Java implementation, which is there we go. So extends limit expr. Okay, so this can may or may not output the same expression, but it doesn't necessarily make a new expression. And that's sort of our problem, is that we're making a new expression, I think. I think that's our problem. Okay. Okay. Can I just resolve this? Oops, wrong one. Okay. Gotcha. So that doesn't quite work. Oh god. Okay. Two catalyst. So if we go find Python buildable Foldable, nullable, determinate state references, stateful, throwable, Genco, data type, children resolve. Oh wait, yeah, wait. Resolve. Check input data types. Wait, what? Oh, shit. Okay. Interesting. So maybe this is actually hatching a type bug and just not looking like it. New expert input data types. Checked. No. Dot input data types. Interesting. This would not be what I thought was going on at all, but I guess it could make sense. But the literal type that we've got is a mismatch. Okay, yeah, this could make sense because we often implicitly insert some casts automatically. And if we're doing stuff at this stage of the optimizer, that might not actually be the happening for us. Let's see if this theory is the case. Yeah, no, data type mismatch, type string. Okay. Well, this is not at all what I thought was happening. And that's, in a way, kind of exciting. How is that a string, though? Okay. Why are you a string? You shouldn't be a string. Oh. Python typing is fun. Our problem here, which, again, not at all the problem I thought I had. Well, no, that shouldn't be a string, should it? Huh. Why? Okay. Let's figure out why it's a string. Okay. Def to catalyst. Okay. Let's go take a look. When we go and we get the constant, this is where we're getting the constant value. Okay. Well, extracting constants. Constant value of type. Okay. Let's figure out where things are going sideways. Okay, it's cost value. Oh yeah, and this is snake case instead of camel case. Definitely need to fix that. Whatever. But this is interesting to me. It says like, hey, what's up? So anyways, I'm fascinated by this. Okay, cool. Problem is that means we're probably not going to fix it today. But it is, yeah, 100% not what I was expecting. It also means that the like thing that I was trying to do to fix it probably wouldn't have. Well, I might have, but okay. Okay, so that it is getting a string. Why is it getting a string? Is that some garbage I did over in the Python code? Or is that... Whoa. Okay. Let's go take a look at our dump to tree implementation inside of UDF. See if we've got something that's like going to be shoving this over to a... So... Here we go. It's also possible just that like Python just doesn't have the type information in the AST when we go ahead and parse it. Let's play with that. Yeah. Okay. Well, okay. So m.expr, m.body, dot value. Dot body dot right. Okay, you're an int. This is good. This means that this is an int when we parse it. Fantastic. So at some point it's getting converted into a string, and we don't know where that is. We don't know where that is. So, okay. If it's a node AST, we... Oh! It's probably this underscore format. Yep. My bad, I think. I think. I'm not 100% sure, but that's My guess is that's the part where we were accidentally coercing it into a string. Let's find out. Ah, okay. So so ah okay, this might be the part where we were coercing it into a string then. Maybe. Who knows? We find out. Okay. Okay. Cool. So we still have a type mismatch, but we have a type mismatch that makes sense. Right? Like it's an int and we expect a big int. Um Whereas before we just string. Okay, well, okay, let's go ahead, let's make that commit. Python, PySpark, SQL, UDF. I'm gonna get commit dash m. Don't call repr on the nodes. Then all of our built-in types become strings. Oops. Okay. Cool. Cool. This is making more sense. Very excited. Um, Very excited. Now, how do we deal with the lack of automatic type so we make it the literal. Question is like, should it be a big int or an int? And if we're doing a binary operator, we could coerce it to. Okay. Um. If write expert dots data type okay to do auto coerce logic goes here, but I think we should have something for that. Auto upgrade the type to the bigger of it. Rep minus r I big int equal rep minus I upgrade. Equal. Yeah. So coerce. Can't spell coerce. 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 Um, Okay, this spelled like course. It's just. Is it? Um. Don't. I feel like there should be something already, but use the decimal type. Oh, let's go take a look. Okay, expression resolver. Resolver. Let's see. Okay. String. Okay. Recursive data types. Oh, okay. No, that's how we. So wait. Um. Uh, so okay, yeah. We could just try and call expression resolver resolve in the result of our upgrade. Maybe. Okay. Expression resolver. Okay. Well, I did say we were going to do this for about an hour, and it's been about an hour. The good news is I now understand what's happening. And we've made some progress, right? Let's some hacks we should explore using resolve and expression resolver to fix our types, to upgrade our types for us, maybe. Okay, cool. And I made a note for future hold. So on that note, I'm going to wrap up and go do things that are not working on Spark. Thanks, Raghav Gupta, for chatting today. Thanks, Pete, for sharing this again. And it's great. I'll see you all around. Have a lovely day. I'll try and stream tomorrow. So where's my phone? I don't know what my calendar is tomorrow. I'll figure it out. But I'll probably be back tomorrow. So if you want to like and subscribe and all that, standard BS, then you can get a notification whenever I do find the time to stream tomorrow. I got eating on jazzercise with the professor. But I'll see y'all around.